Alright, so this is NCCER Instrumentation 3, Module 1, Control Valves, Actuators, and Positioners. PowerPoint's up here. So, some of this stuff, a lot of times, with a lot of this information, you probably have had a lot of it in Instrumentation 2, but it's kind of a refresher, and then they'll go more into detail with what some of this stuff is. You can tell page 1 is all trade terms. Like, this is a ton of information on page 1, and you need to know what a lot of this stuff is. So like actuator, you need to know what an actuator is for moving the component that converts electrical or fluid energy to mechanical energy to position a valve. So you would put like an actuator in the front of that control valve that would actuate the valve. ASTM is a specific standard. I just hit some of the important ones. You should know what a globe valve is, ball valve is. You should know what a butterfly valve is, check valve, and all there's not all of them, but a lot of them. You can see the cutout valves over there against the wall. So they have like the first one closest to us is a big ball valve. The next one's a plug valve. The next one's a gate valve, and so on and so forth. I don't know that I don't have every one in the book, but feel free to go over there, mess with them, see how they work, look at the insides and stuff like that. What y'all think the school paid for those valves?
About each one, I'll say about 8,000, 7,000.
The whole table was about 20, which is nuts. That's crazy to me. Cut out valves and stuff like that. I thought it was crazy. Check valve. Let's see. Gate valve. Gate valve is going to be your most common valve. Globe valve. There's a knife valve over there. Lapping. If you've never heard of lapping, so a gate valve has a cylinder or a disc that comes down and like cuts into the bottom of the valve, and over time that can corrode and stuff like that. So you might hear something called lapping in valves. A lot of times you might hear that with like an engine repair and stuff like that, and they're actually lapping in the valves to make sure lapping is just making two very smooth mating surfaces that close off. Needle valve, like they have the little gray one right there. You have a little bitty needle valve cut out sections that you can go look at, but it's literally just a little needle that goes back and forth. If you guys y'all didn't do the hydraulic trainer with Mr. Wally, did you? That'll be an extra one, like you have a needle valve on that to set the pressures. For that, y'all did packing with Mr. Wally though, didn't you? So packing, everybody knows, you do any kind of packing at
No, but like, I kind of have done it at work, like with like a little stuffing and then
the stuffing that goes inside the bind. Okay, yeah. Like we have a pretty good trainer in there where you like actually pull packing out and like cut it to length and shove it back in there and stuff. That's the white, the PTFE packing, the white stuff that you had to shove inside and had a clear case.
You had to put it different.
You had to change your opening every 90 degrees, so that's packing. Plug valve, so plug valve is like the second one in there, and then positioner. So positioner would be something like this. So this would go on the front of a control valve. So it's got different mountings. So you see the big tall valve over there. It's got two openings in the front. This would screw to the front, and then it has a mechanical linkage. And this is what actually connects to the stem of the valve. So as if the valve moves up to open, like this would be open, and then it moves down, this would be closed, and this tells...
It's like an actuator then.
It's like an actuator. But this is a position to make sure that your valve is in the right position. So, yes and no.
Yes.
But this is what like your PLC or something like that is talking to tell your valve, to not only tell your valve what position to be in, but also to give a
precise.
Well, not precise. To give a position back to the PLC to say, hey, I'm at 50% or something like that. Or if something's wrong, like it might say like the valve's completely open where you're telling it to be at 50%, but it's not doing anything, like that's a kind of indication like the valve is stuck or something's wrong. You've even got more trade terms on page 2. Seat, throttle, torque, valve body. All these are important. Like I would recommend reading through and any of them that you don't recognize. Of course, they're gonna talk about them in the chapter and stuff like that, but you want to have an idea of what these are. So I'm on page 2. My first highlight is the second sentence on page 2. So I've got, as shown in figure 1, valves are used for 3 primary purposes, and I have all 3 bullet points highlighted. To control the volume of flow, including shutoff, to control the direction of flow, and to regulate or relieve the pressure at which the system operates. Good?
Yep.
Okay, yes.
Right. So that's my first highlight. Then he goes into section 110 on valves. So they show some different valves. They talk about globe valves, gate valves, knife valves, ball valves, and so on and so forth. And you can kind of see a few of them up here. Like this is, anybody remember what valve is good for flow control from Mr. Wally's class?
Yeah, no.
That's gate, right?
Never use a gate valve. You never should use a gate valve for flow control. Everywhere I worked has used it for gate valve, but it is globe valve. So the reason you wouldn't use a gate valve, so the inside of a gate valve kind of looks like the disc that's coming down kind of looks like that.
Yeah.
And if I shut it off at like 50% or whatever that is, that water or material is still going to be pushing this, and it's going to corrode the bottom of that. So whenever I go to try to shut it, it's not going to close. So you are never supposed to use a gate valve for flow control, but everywhere I work has and does, but shouldn't. You should use a globe valve.
That is weird. Doesn't that have to do with the engineering schematics? Or whoever puts designs in?
Well, it's just that people like people need like fudge factors to make something work right or something like that. So they use stuff they're not supposed to.
Okay.
It might have been engineered correctly, but 20 years down the line, they might say like, hey, we need half flow, so they just shut it off to half flow or something like that. Like it just depends on the circumstance.
Because you can wear out the material as well.
Yeah. Like this bottom is not. It can be made out of metal, but it can be made out of like PTFE or some type of rubber or some type of material. And as stuff's running across the bottom, it's eating that up.
Yeah.
111. First sentence of 111 globe valves is an online test question. This is the only place you'll see it. 111 globe valves. Globe valves are used to stop, start, and regulate fluid flow. Everybody see that?
Yes.
So that will be an online test question. Will only be in your book. So you want to make sure you highlight that and note it somehow to go back and read before the test. So you can see the picture of the globe valve up here on the board. So the most important part, like you have a disc, and I think you went through, I get my levels mixed up, but I think you went through in 2 and talked about the different types of discs you can have. But this is the seat, so the disc actually goes and pushes down onto the seat. But you can see the direction of flow, like goes down and then up and then out. So pushing against this, it's easy to regulate flow because you're just closing that orifice right there. Down at the bottom of page 2, last paragraph on page 2, the first sentence is highlighted. Globe valves can be arranged so that the disc closes against the direction of fluid flow, which is called flow to open, or so that the disc closes in the same direction as fluid flow, which is called flow to close. So looking up at this one that's on the board, is that flow to open or flow to close?
Flow to open.
Flow to open, because, can y'all see my mouse on the screen? Because it's pushing up on that disc, right? So that's technically helping open the valve, so that would be flow to open. But if I had flow coming in from this side, going the opposite way, technically it'd be pushing down and that would be called flow to close. That is an important concept to note. A lot of people get that mixed up in their head and stuff like that, so make sure you know that one. The last two sentences of that paragraph are an online test question. So it's like almost the second half of the paragraph. When the disc closes in the same direction as the fluid is flowing, the kinetic energy of the fluid aids closing but impedes opening the valve. This characteristic makes the globe valve preferable to the gate valve when quick-acting shutoff is necessary. So globe valves are good for quick-acting shutoff. Online test question. Moving on to page 4. Still talking about globe valves. The second sentence on page 4 is highlighted. The most evident shortcoming of the globe valve is the high head loss or resistance to flow from the 2 or more right angle turns of flowing fluid. So you have a lot of head loss. If you're looking up here on the board, like you can see this, the fluid flow changes directions like 4 times. So it goes down, then up, then down, then out. So there's a lot of head loss. Like there's going to be, like you're going to have some pressure loss through a globe valve. That's the disadvantage, right? If I had like a ball valve or a gate, they show me. This would be like the inside of a gate valve. So if I open this all the way up, there's not going to be any kind of resistance to fluid flow, right? So there's not going to be any, that's your head loss. You're not going to have any head loss through a gate valve. But whereas you're looking at a globe valve, it's going to, anytime the fluid flow is going to change directions, you're going to have some head loss.
That's not a test question though, right?
So I'm not going to tell you. Like that's going to be a question either somewhere in the book or on the test. Right? This next highlight is kind of a weird one. It's got a few different sentences highlighted, but they all talk about the same thing. So my first one is the last sentence on page 4 that goes into page 5, and this is an online test question. The valve disc shown in figure 4A is called a ball disc because it is rounded like the surface of a ball. It fits on a tapered, flat surface seat and is generally used on low pressure, low temperature systems. So ball disc, low pressure, low temp. Might even write that up by figure 4A. Ball disc, low pressure, low temp. The second paragraph on page 5, this is all still part of the same highlight. The first 2 sentences of the second full paragraph on page 5 is highlighted. The composition disc is replaceable. It is available in a variety of materials that are designed for different types of service, such as high and low temperature water, air, or steam. So the composition disc is good for high and low temperature water, air, or steam. So that's the one in the middle up here. And then the immediate next paragraph, first sentence. The plug disc, or the plug type disc, shown in figure 4C, provides the best throttling service for globe valves because of its configuration. So this one right here, the figure 4C, is the best for throttling. Right? So when you think of ball disc, think of low pressure, low temp. Composition disc is high or low temperature for water, air, or steam. And then the plug disc is the best for throttling. Can I go with that? Yeah. Out to the side of those highlights, I just wrote, like that's where I wrote my note, all different types of plugs. So those are the 3 different types. There's a bunch of different types of plugs, but those are the 3 main different types of plugs. Something to that effect. Alright, moving on to page 6. Gate valves. So gate valves are going to be your most common type of valve, probably that you mess with in the industry. Gate valves
Yeah, I see that.
Yeah.
Yeah, that's exactly what.
are most common, and also the biggest pain in the butt to open and close whenever they've been sitting there for a minute. I have the first sentence of 112 highlighted. Gate valves are only used to stop or start fluid flow, not to regulate or throttle it. And again, I preface that with should only be used to stop or start fluid flow, because everywhere I've worked has used it for throttling, but you should not. So, over on the right-hand side of the page, the sentence before those bullet points. No, never mind. I don't have that highlighted. They go through some of the disadvantages of a gate valve. I don't have it highlighted. But you can read through, anytime you see bullet points or anything highlighted, like it's probably a good idea to read. Like I said, in order to get like the best grade on this test, you gotta read the whole chapter. I'm not gonna read the chapter for y'all or anything like that, but I'm gonna give you all my highlights and talk about what I've experienced in with my experiences and stuff like that. It's gonna tell you the disadvantages, and then on page 7, the bullet points talk about the different types of discs. So you can see up here on the board, or in figure 7, you got different wedges. Like you got the solid, the flexible, the split wedge. Like these are just different wedges that are going to help close this off, depending on what you're flowing through this. Some stuff might be easier to shut off having a flexible disc than it would be having like a solid metal disc. It's just going to depend on what material you're flowing through there. Nothing else on page 6 and 7. Flipping over to page 8. 113, knife valves. So I don't think there's a knife valve over there. There's a butterfly valve that's kind of the same, but not really. I've never, in my experience, I've never had to use a knife valve. I think these are used in wastewater management and stuff like that, where you're going to have like a slurry or like sludge mixture, stuff like that, in order to cut through something to get something closed. My highlight for 113 is the second and third sentence of 113. As the name suggests, a knife valve contains a thin, knife-like disc that can cut through deposits and solids such as resin slurry. For this reason, knife valves are used in slurry and waste lines and some similar to low-pressure applications. When you think of a knife valve, think of low-pressure applications. A lot of times I get ahead of myself with this stuff, and they'll say something that I'm just about to tell you all to highlight, but just kind of how it works. This chapter does have a ton of online test questions, so make sure that you guys are reading and studying those before you take this test. Ball valves, 114. So you've got the ball valve right here. So you can see I'd recommend looking at that valve, but it's just going to be a quarter turn. Any type of quarter turn valve is usually going to be at some type of ball valve. So you can see like this is open and free flowing, and then when you turn it, that ball just kind of shifts and then it closes off both sides. On page 9, the second full paragraph, first sentence, is an online test question. In general, ball valves are the least expensive of any valve configuration, and they have low maintenance costs. Least expensive and low maintenance costs. Last paragraph on the page. Online test question, second sentence. Last paragraph on page 9, second sentence, online test question. The most common seat materials are virgin tetrafluoroethylene, filled TFE, nylon, nitrile rubber, Una-N, neoprene, or combinations of these materials. So if you look up here on the board, you see these little white cavities right here? That is to say, that's the seat. So that's where you'll have like your nitrile or rubber or something like that. This is actually circular, and you can see it. Like if you like go look at the valve over there, you see like an O-ring or something, and that's what actually comes in contact with the ball that actually forms the seal. So those seals can be made of all different types of materials. Good. Page 10. Man, there's a lot of them. This is most online test questions that I teach. I teach electrical and instrumentation. This has a lot of online test questions, so make sure that you guys know this stuff. Plug valves. So plug valve can change the direction of flow in multiple different ways and have different types of plug openings. My highlight on page 16, online test question, second paragraph, second sentence.
Wait, what page you on? 10?
10. Did I say 16?
Yeah.
16.
I don't know what I was. I've done that twice today. Sorry. Page 10, 115, second paragraph, second sentence, online test question. The most common substances controlled by plug valves are gases and liquid hydrocarbons. So I don't know, I've never worked in a refinery, but I would assume they have a lot of plug valves. So they're changing the direction of flow from one thing to another. Liquid hydrocarbons, that's what refineries are messing with for the most part. Last paragraph on page 10, first sentence is an online test question. Plug valves are normally used only for on-off applications, particularly those where frequent operation of the valve is necessary. Plug valves are normally used only for on-off applications, particularly those where frequent operation of the valve is necessary. Online test question. Page 11. Second paragraph, first sentence, online test question. Multi-port valves are particularly good for transfer lines and for diverting services. Online test question. Second paragraph, first sentence. Multi-port valves are particularly good for transfer lines and diverting services. So you can look down and you can see all the different types of valves, like the FA 1, 2, 3, 4, and 5, and what they do. So it says what it does at position 0, turn it 90 degrees, turn it 180 degrees, and it can tell you which direction the fluid is flowing. So for FA3, that's going to be your plug right there. At position 0, it's going to go right and down. Not turn it 90 degrees and allow all three ways to flow. Turn it 180 degrees and it's going to go left and down. Does that make sense? Page 12. Page 12, you're going to have the figure 19, which shows these different ports for the plug valves. Highlight figure 19 and each plug type as an online test question. So you're going to have the round port plug, the diamond port plug, the rectangular plug, which is the standard. They're going to show you a picture or something like that and ask you what the different, or might even ask you what the different types of plug ports are. So round, diamond, and rectangular. Butterfly valves. So these are one that just has a flap on the inside, and you turn. There's one of them over there that you can mess with. These are good for throttling. I say that they should be good for throttling, but you can see the big disc. Like you can see the butterfly valve on page 13. Or this is even a better picture. So you can see your hand lever, and usually like the valve that's over there. These hand levers have a little spring-loaded trap kind of thing, so you pull up on it, and it has different grooves that trap can go into, so you can open it like 50% or 60%, something like that. So you can open it incrementally into that. These don't look like they have, maybe they do, I don't know what that little lever is right there, but you can just see how that disc opens and closes and comes in contact with the gasket. In my experience, these are not good at completely shutting off fluid flow. Like there's usually always something that's leaking by with these. They're better for throttle. But my highlight for butterfly valves for 116 on page 12 is the last sentence of the first paragraph in 116. Butterfly valves are especially well suited for handling large flows of liquids or gases at relatively low pressures and for handling slurries or liquids that contain large amount of suspended solids. So that's the last sentence of the first paragraph of 116. Butterfly valves are especially well suited for handling large flows of liquids or gases at relatively low pressures and for handling slurries or liquids that contain large amounts of suspended solids. I go with that? Moving on to page 13, we've got another online test question. Third paragraph on page 13, last sentence. Valves used for corrosive applications have a stem seal on the inside of the valve so that no processed material can come in contact with the valve stem. So you can see in this picture right here, they put a seal right here so that if something corrosive is flowing through this, it can't get, usually this is some type of stainless steel or something like that, where you don't want acid or something like that to get up to it. So they're just saying that they put some kind of seal in between the opening of the body and the stem. Good? Needle valves, 117. These are going to be pretty small for the most part. I mean, if you look at the one over there, like usually it's going to fit in your hand, something like that. 117, second paragraph, first sentence is highlighted. A slight movement on the valve stem permits a very gradual change in the size of the valve opening, allowing precise control of the flow. Second paragraph of 117, first sentence. A slight movement of the valve stem permits a very gradual change in the size of the valve opening, allowing precise control of the flow. Skip a sentence, and the last two sentences of that paragraph are also highlighted. They are typically small and used where flow rates are low. Precision rather than high flow volume is their advantage. So a needle valve is very precise. One, 2, 0. Last thing on page 13, first sentence of 1, 2, 0 is highlighted. Actuators provide the power to position a valve in response to a signal. Actuators provide the power to position a valve in response to a signal. I wish they gave me that. Flipping over to page 14 and 15.
Would it be a test question?
I'm not telling you whether it's a test question or not. I'm only telling you when it's an online test question. So the online test questions will not be on there. So when I say, you know what I'm saying? Like, you know how they're adding more? You know how you have test questions that aren't on that? That, when I say online test question, it will only be in the book. But what I just gave you, yes, it's a practice test question. But I'm not, like, between practice test, supplemental exercise and the module exercise, I don't differentiate. I only tell you whenever it's going to be an online test question that you won't see anywhere else. So that's the only one that's, it's kind of, yes, that one's on the test, but I'm not gonna differentiate, like it's y'all's job to go back and look through and figure out what is what. On page 15, still talking about needle valves, or no, valve actuators. Second, I guess it's the first full paragraph. Second sentence is highlighted. Some disadvantages are that they have limited power, limited seat shutoff capabilities, and they operate rather slowly. So some disadvantages are they have limited power, limited seat shutoff capabilities, and they operate rather slowly. First full paragraph, second sentence. These next two highlights are usually the harder ones for people to grasp in this chapter. So just try to wrap your mind around these. 121, power to open. On the right-hand side of the page, top right, that first and second full sentence in the top right of the page are highlighted. This type of valve and actuator is known by the terms power to open, air to open, fail close, or spring to close. Each term describes the valve's basic behavior. Without the control medium, it stays closed. To open it, the control medium must be supplied. So, looking up here on the board, which I think you have this picture. Yeah, you've got this picture on the next page, but up here on the board, this is power to open. So you can see, like looking at this, like the top of this valve right here, like you can either put air coming in the bottom of it or air coming in the top. And then there's a big gasket in here to differentiate. Like you can see the big yellow disc, like that's right here. With this, like if you notice, you see my spring up here on this one. If you look at that one, the spring is down here. So not the same type of valve. But if you're looking at this, we're talking about power to open. So our air is coming in the bottom side of that little bonnet. It's not the bonnet. It's hitting the bottom side of that diaphragm and pushing up on that. So I have to have power to open. I have to have. So this is power to open. I have to have air to open. I have to have. If air got cut off of this, what's this valve going to do? The spring is going to push down on this and it's going to close. So it's going to be failed closed or spring to close. Does that make sense? I know that seems super easy, but I've just noticed over time, like this is where people get confused.
And the same thing, fail to close, spring to close.
All of that means the same thing. So if air got cut off through this, it's going to fail closed because of the spring. But spring to close, air to open. Our power in this instance is pneumatic power. So power to open. Do that one. Moving on to 122, power to close. The first three sentences of 122 are highlighted. Valves may also be designed so that the spring in the actuator holds the valve open in the absence of the control medium. To close the valve, the control medium acts against the spring. This type of valve is known in terms power to close, air to close, fail open, or spring to open. So the same thing that we just talked about, but different. You can see my air supply is now coming in the top and hitting the top of that diaphragm. So it's pushing down on that. So that is air to close, power to close. If my air pressure failed, the spring will push up on the diaphragm and open my valve. So that it's fail open. The spring also does the same thing. Spring is trying to constantly open this valve. So that's spring to open. Good? Make sure before you take the test you wrap your mind around. Make sure that those are all like.
Wait, these are an online tests.
They're not.
Okay.
But they will be on the test.
It's kind of tricky.
But you just need to know like all the different. They're kind of like synonyms, like the power to open, air to open, fail close, spring to close. Like all those mean the same thing essentially. So you need to know both sets. Like all the words are for one and all the words for the other.
So whenever something like that happens, so is that what it's called, like stroking the valve?
Stroking the valve just means moving the valve. Like that just means sending a signal to the valve to like make it move to a certain percentage of open or closed. Okay. So that would be stroking the valve.
Like if it's stuck or something.
Maybe trying to find the actual position of it,
Or that, or if you had to calibrate it or something like that. Yeah, stroking the valve just means moving the valve. Moving on to page 16, so you can see those Like they have an electric motor actuator in figure 25, so that's actually an electric motor that moves that back and forth. And then you can see the position indicator at the top, so it'll tell you if it's open or closed. They have the same pictures that I just went through. On page 17, the first sentence on page 17 is highlighted. The term fail as position means that on the loss of the control medium, the valve remains in whatever position it was at the time of loss. If you have an electronic actuator, that's usually how those are built. Because if electricity is cut off from a electric actuator, it's going to stay wherever it was for the most part. They can have some that make them close, but if it's electric actuator, it's probably going to stay wherever it is.
These, they always have springs, right? Either or. Either
Well, I mean, for
closed,
the
open.
pneumatic valves, they're going to have some type of spring in there, yes. But like that ball valve in the top right, that doesn't have springs in it. There might be little springs or something like that, but like this one right here, like there's not springs inside of that one. The springs would be for the gate valves for the most part, but these are, well, this, I think that's still a gate valve. Yeah. Not all of them have springs, but the pneumatic ones will. 130, principles of operation and construction of various positioners. I think that's where it made it go. Okay. In 130 on page 17, the third sentence is highlighted. Their primary function is to maintain the control valve orifice between 0 and 100% directly in proportion to the controller output pressure. So that's for this thing right here. This is a little bit older one, but the function of this is to help maintain the valve orifice somewhere between all the way closed on this side or all the way open. Next paragraph, I've got the third sentence highlighted, almost all the way in the bottom left of page 17. To create movement, the positioner compares the stem position of the valve actuator to the signal from the controller. So that's saying you've got your little mechanical arm right here. This is what's connected to your valve, right? So it compares this to it's usually instrument in. So this has a pressure on it. So it compares whatever the pressure is on this or whatever it's telling it to be to make sure that it's the same as wherever it should be in like 0 to 100% open or closed. So this is just comparing the input signal to where the valve actually is, and if it's not the same, then it will change the output pressure and change that valve to where it should be. At least that's how the positioner should work. 131, direct or reverse acting positioners. Third sentence of 131, the bottom right of the page, is highlighted. Direct acting positioners and controllers, for example, increase their output signal when the measured medium increases. When the measured medium decreases, the output signal decreases as well. I think I have, they're going to show, so on the next page, on page 18, they have this figure 28 at the top of the page. Mark this figure as an online test question. So direct acting, as the signal goes up, the output goes up. Decrease output. Reverse acting would be the opposite. So just highlight figure 28 as an online test question. One, 3, 2. I've got 2 online test questions in this one paragraph. The first one is the second sentence. And this is for, you need to know this is for pneumatic positioners, so I just underlined the heading of this. Second sentence, they are especially critical for process control loops with long transmission lines between the controller and the actuator. They are especially critical for process control loops with long transmission lines between the controller and the actuator. The immediate next sentence is also an online test question. So 2 separate questions. These positioners are typically supplied with 3 pressure gauges. 3 pressure gauges on the front of this that monitor the supply signal, or monitor the supply, the signal, and output air pressures. So you can see the picture on there, or you can see this one right here, like 3 gauges on the front. I've got nothing in analog positioners, which would be this. When you guys hear analog, what do you think?
Old school.
It's usually what people say. So analog does not mean old. Like I wish people would stop saying analog means old, because it doesn't. What's your most common instrumentation signal?
It's more hands-on, I guess. Analog.
It's not. What's your most common instrumentation signal?
4 to 20.
4 to 20. 4 to 20 what?
Yeah.
Milliamp.
Milliamps. 4 to 20 milliamps. So I can have anywhere between 4 and 20 on a graph, and then this thing can be anywhere, like my signal can be anywhere in between, right? That's analog. So analog can be fluctuating. So analog is varied. It doesn't mean old. It means very, 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 very. It's not very. When you hear just digital, what do you think?
High tech.
Not really. I mean, it is and it isn't. What I want you guys to think of is a little different. So when you hear digital, this would be analog.
Straight lines.
Digital. I want you to think binary, 1s and 0s, on, off. You only have 2. You only have 2 positions that you can be with. I know I don't have the best handwriting. Digital, binary, 1s and 0s, on and off. So that can only be. It's like a light switch is a. You can also say digital or discrete. All this is going to be on or off, 1s or 0s, stuff like that. Like, I can't remember if y'all did like binary, where you figured out like words and bits and stuff like that with Mr. Waller, if that's what it means. At some point you'll get it, or you've had it. But you can do. It's definitely with me. You can do like different things. I'm not going to get into that because there's a whole half a chapter on it. But digital would be like if I had a PLC. Like this is a PLC, right? Like you can have. I have analog inputs. So I have like an analog input would be like a pressure sensor. Pressure sensor you would never want to be like 1 or 0. You'd want a pressure sensor to be like from 3 to 15 psi or 0 to 100 psi, something like that. So that's going to vary. So I would have to, if I was bringing that signal into a PLC, I'd have to have an analog input. If I have a digital input, that's where I have stuff like push buttons. Like a push button can either be on or off, or a light switch can only be on or off, or like a float switch is only going to be made or not made. Those are discrete or digital devices. Does that make sense? So on page 19, 134, I underlined the heading. Online test question is the last sentence of 134. They are preferred for their accuracy, reliability, and ease of use, as well as the wide range of information they can provide about the control valves in a process system. Next paragraph, below the green note, the second sentence is highlighted. The integration of smart positioners with plant asset management systems offered many benefits. I've never worked anywhere with a plant asset management system, but that's where somebody literally, like every piece of equipment you get put in, installed goes into a system, and the system can tell you like when to calibrate it, when it was installed, what it is, like
Wow.
it would be nice to have. I've never gotten to work anywhere that's had it. Like that would be awesome, but I've never worked anywhere that's had it. Let's see, all the way in the bottom left of 19, I've got the sentence that's got the hard to access through the end of the, I guess it's just the last two sentences of the paragraph are highlighted. This is very useful for valves that are in hard to access locations or hazardous environments. Remotely obtaining valve condition and performance information reduces the need for maintenance personnel to visit hard to access and or hazardous sites. So yeah, it would be awesome to have valves that tell you what their performance is and stuff like that, but obviously the more you get into that stuff, the higher dollar that stuff is going to be. But yeah, I have zero experience with that, or I've done like that
Logistics stuff.
stuff like that. Yeah, like I could see, like if you were building a brand new plant, I could see something like that, like putting in a plant or a plant asset management system that'll tell you like, and you could put stuff like that into distributed control system, and it'll tell you like, hey, it's about time to calibrate this and stuff like that. But it almost has to be set up on the front end of like building a plant. It would be so hard to go back in and
You
find
have to change
every
everything.
piece of equipment and say what age it is and when's the last time it's calibrated. Like it's almost unthinkable to go in
You
and
have
do
to have
something like that.
one person for each unit.
Yeah, I can't imagine being a part of doing something like that. So to me, it has to be done on the front end of building a plant or something like that. 140, but that's the end. Just keep. Valve selection factors. Nothing on 19, flipping over to page 20. Second paragraph on page 20, first sentence is highlighted. A mixing valve is designed with 2 inlets and 1 outlet. Out to the side of that, I wrote 3-way valve. Mixing valve is a 3-way valve. All the way at the bottom left of the page, right above where you see remotely mounted DVC, online test question. I've got that one heading sentence highlighted. The following concerns should be considered during valve selection, and I highlighted all the bullet points. So just the heading, you can just highlight the heading or just the bullet points, but you're going to need to know what temperature will stuff be operating, what pressure, what size. Will this valve be used for on-off or a throttle application? What kind of stuff is going to be running through this that'll cause erosion? What kind of pressure drops allowed? What kind of differential pressure will it be operated against? How will the valve be connected? What type of environment will it be in? What kind of fluids being handled? What's the life expectancy? All these things have to be thought of before installing a valve in a new spot or something like that. On page 21, I highlighted the first bullet point on page 21, I highlighted the whole thing. You're going to need to know the whole thing for that one. What kind of pressure drop is allowed? Globe valves exhibit the largest pressure drop or head loss characteristics, whereas ball valves exhibit the least. Gate valves are the most, globe valves are the most, remember, because that flow has to change directions. For a ball valve, it can just flow straight through there and there's no obstructions, no head loss. very little. Did I go with that?
Okay, the last one you said, the following concerns, that's tests, online test, right?
Yes, that's an online test question with all the bullet points.
Okay.
And then that first bullet point on page 21, it's
That's
not,
part of it?
it is part of that one, but it's also one in itself.
Okay, okay,
So some of the highlights will be for more than one question.
okay, got it.
Some, cause like y'all seen where they use like, and I call it like this review at the back, I call the mod review, like the blue one at the back, that's what I call the mod review. So everybody's seen where they've taken a mod review question and used that on an online test. So some of these highlights that I give you are for a module review question as well as like another test question or something like that. Valve marking and nameplate information. All the way in the bottom left of page 21, I've got an online test question. The Manufacturers Standardization Society, MSS, first developed SP25 in 1934. In 1978, SP25 was revised to incorporate all the changes that had developed since 1934. Online test question. That's one of those online questions that I think is stupid. Like, who cares? Like, who cares? It was in the 30s. That is not something that you guys need to remember for anything except for this test, right? But it'll be on or it could be on your test. Right-hand side of the page, that first full paragraph on the right-hand side of the page, the second sentence is an online test question. The bridge wall marking is usually found on globe valves and is an indication of how the seat walls are angled in relation to the inlet and outlet ports of the valve. So you can see what a picture of so you can see like the inside of this globe valve. You see how they have, like the flow will go down and then across. It doesn't really show back out. Oh, it's these. So it doesn't show the flow, it shows the seats. So see how the wall on this seat is slanted down, and then so is this one. So the bridge wall markings will show this on the outside of the valves. And there's one, you have to look on the back side of the valve and the globe valve over there, but it shows bridge wall markings. So this shows you how the valve is configured on the inside, because you can't just open up these valves. That one you can look on the inside and see it, but this shows you how they're actually configured on the inside.
Okay. And that usually is on the
It's on the globe valve. Like
it's on the globe valve itself?
Yes.
Okay.
Look at that globe valve, and you'll see it'll either be this or flipped around the other way on that globe valve. The last sentence on the page that continues on to the next page is highlighted. If a gate valve has a flow arrow, the arrow is provided because the gate valve has a double gate. So that's what I was, the picture was from the other one. Yes, they can have a double gate. Page 22 and 23, rating designations. So this is just rating the valves. Like some valves are good for air, some valves are good for water, some are good for acid, this, that, and the other. On page 23, that first sentence and all the bullet points are highlighted as an online test question. Other typical designations are given as the first letter of the system for which they are designed. So you have A is for air, G gas, L liquid, O oil, W water, DWV drainage waste and that service. You'll have those online test questions. Trim identification 152. Second paragraph, first 4 sentences are highlighted. Trim identification markings for gate, globe, angle, and cross valves or valves with similar design characteristics consist of 3 symbols. The first indicates the material of the stem, the second indicates the material of the disc or the wedge face, and the third indicates the material of the seat face. size designation. This is important. Second sentence of 153 is highlighted. The appropriate pipe connection size for the valve is provided as a nominal pipe size. Remember, nominal sizes do not correspond to actual measurements. So you could have like a size 8 pipe. That does not mean that that pipe is exactly 8 inches wide. That is a nominal size. So that's just saying it is a number 8. It is a nominal size. It will be close to 8, but it won't be exactly 8. Nominal size. Thread markings. 154, last sentence is highlighted. Fittings with left-hand thread must be marked with the letters LH on the outside wall of the appropriate opening. Left-hand threads are usually only going to be on stuff that spins. Like if anybody's ever messed with a lawnmower or something like that, a lot of times the blades on a lawnmower have left-hand threads because the way they spin would unloosen them. Or if you were like on a bike sometimes has left-hand threads because as you pedal, you don't want to loosen your pegs off your bike and stuff like that. I haven't had a lot of experience in a plant having to mess with left-hand threads as an electrician or instrument tech, but just know they're out there. I've also tightened snot out of a left-hand thread bolt on a mower or something like that because I didn't realize it was left-hand thread.
I did that when I was like 15 to my dad's weed eater.
Yeah. You learn the first time you do it, you either break it off or
Like 13, 14 years old.
yeah, usually you have to learn that one the hard way.
Yeah.
You've got, I don't have anything else on page 23. Flipping over to page 24. You're gonna have a symbols. You have all these symbols. Just know, I tell everybody, like on drawings and stuff like that, where do you go to find what the symbols are on the drawing? What's that called?
Tape or con.
Close.
No. Oh.
Starts with an L. Legend. You
Legend.
go to a legend to find the symbols. Just know that different drawings at different places, like you might have this picture as a gate valve, but that doesn't mean that's the only symbol that's ever used for anybody for a gate valve. Like they change, like usually it looks like some type of bow tie symbol or something like that, but you can also have like a globe valve that has a little sort of like, yes, it's common, yes, a lot of people are going to use it, but they also might not, and they might use something else. Make sure that you're referring to the legend when you're reading documents and stuff like that. Like these will be common, but not always exactly right. All right, let me stop